Okay. It's like moving here. Okay, okay. Let's say, for example, here you have so is this one regular or irregular? Irregular, because look how these are coming in different patterns. That is what we mean by a rhythm. Okay. So I think those of you who finished the analysis, Sarah, did you have it done? Okay. I think that's easier for you now to say which one is which. Yes?
What do you mean? Oh, okay, yeah.
Yeah.
Yep.
So we have two kinds of rhythms. We have ventricular and atrial. So when we check the R waves, so that one, when we do between R waves, okay, so which one is the R wave and which one is the, okay, let's see that one. So this one is what? The P wave. This is what? Q, this is R, this is S, this is D. Sometimes there is U wave. Okay? So P, Q, R, S, T, and U. It continues like this. These are called the waves. Wave. Okay? So we'll see that. Okay. When we do between R and R, that is called ventricular. When I say R, R, they are not regular. That means the ventricular rhythm is irregular. When I do P and P, between this P and this one is P, then the next P is irregular. This is P. It's irregular, yes? It means that's what? Atrial rhythm. So that's why we have two kinds. Yeah, you see here, ventricular and atrial, yes? So RR depicts what? Ventricular, and PP depicts atrial. Then the red. Now once you determine the rhythm, you go to red. Okay? So how do you determine? We have two kinds of reds. What are they?
Regular and irregular.
Regular and irregular. So basically we have two kinds of reds, ventricular and atrial, the same reds. Okay? Now, your rhythm is very important to calculate the red. Yes? How? If the rhythm is regular, you do which method?
1500.
1500. If the rhythm is irregular, you use what? 6-second method. Okay? Now, how do I do the 1500 method? How do I do the 1500 method?
Count the boxes.
Huh?
Count the boxes between two R's.
Yes. Let's say, if it is regular, let's say, okay? You take R and you count the little boxes that are between this and this. Let's say if you get 22 little boxes between the tip of this R and the tip of this R, what do you do?
1500.
Divide 1500 by,
22.
so that will be your heart rate. Yes? So that is in case of what? A regular rhythm. So when it is irregular, then you use what? 6-second method. So how do you do that? You count a 6-second strip from here to here, and then count what? How many R waves are between that, and then you multiply it by 10. So let me, here for example, here on like this kind of papers, it's always written that there is like lines here. Can you see? So each line is 1 second. Okay? From this line to this line is how many seconds?
1.
1. So this is 2, 3, 4, 5. So 6 seconds means from here to here. Yes? Then take how many QR rays are between this and this. Okay? Let's say you have 6 QR rays, what do? You multiply 6 by 10, or if you are a lay person, you can do any multiplication, just do 0 after 6. 6 times 10, or put 0 after 6, which will be 16. The heart rate will be how much? Let's say if you have 7, what will be the heart rate? Huh?
70.
7 times 10 is 70.
70.
Got it? Clap for me. Okay, clap for you. Sarah wants clap for
No.
me.
Maybe next time.
Okay, clap for you. Don't agree with that?
I told him clap for you.
Yeah, Franklin will wake up when you clap for him.
Yeah.
He was sleeping there, but I told him clap for you.
Okay, so that will be the red. Then the next one will be P configuration. It means the P wave, as you see here, the P wave is always what? Can you see a P wave? It should be always upward, round. Can you see here?
Yeah.
Upward, round, and there should be one P wave for each QR race. For example, here, is there one P wave for each QR race? Is there?
No.
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 No, it means there is a problem. Because this is T wave, okay? So this is P, there is no P wave here. There is one here. There is no P here. There is one P here. It means it's not consistent. There should be one P wave for one each QR race. Let's say one husband, one wife. So every time there should be consistent pattern of one each.
Also, in case it doesn't come, for example, that P in one, it doesn't come. Like when you will do the rate, for example.
No, this is not the red, and this is different. We are doing P wave. P wave is configuration. Just see
Yeah. Oh,
see how is the shape.
Oh, the shape of
If
the-
it's coming upward, how is the shape? And there should be one P wave for each QR race, and it should be symmetrical. So if all the P waves are like that, it's a normal P wave. If the P wave doesn't look like that, then it's abnormal P wave. It means there should be something abnormal to the P wave. Okay? Then the next will be what? PR interval. So PR interval means the distance from the beginning of P to the beginning of Q. And you count the little boxes and multiply it by, because we said one each box is how much? 0.04 second. So multiply that and then you will get.
Should be called PQ.
Huh? Yeah, if you go to Britain, this is PQ. But here is PR.
Why? Doesn't make sense.
So then the other is QRS duration. So QRS will be what?
Beginning of Q,
Whereas beginning of Q here
end of
to
S.
end of S. How many little boxes? Multiplied by 0.04. Okay. So because you are doing it on your analysis at the end, I think you know what, you know the whole thing of this one. The other thing that usually is also asked is QT interval. QT is what? From the beginning of
Q,
Q to the end of
T.
T. Okay? So count the little boxes, that's the longest duration we have. Okay?
But isn't there a formula for that one?
Huh?
Isn't there a formula for that one?
Yeah. Yeah. You do it when you analyze. It's called Bazet's formula, or there is also a formula to calculate, which is QT plus 1.75 times what? You'll see it. Let me show you on page. Go to EKG analysis. Go to the EKG analysis. You can go to 200. page 198.
So go to like the logs, analysis logs,
Huh?
right?
Go to page 198 on your EKG analysis.
Yeah.
So you can see here QTC is called corrected. QT is equal to the QT plus 1.75 times rate minus 60. Or you can go to online and there is what we call Bazet's online calculator. You can do it online. QTC calculator, this one. So write the heart rate in beats per minute. Let's say how much is your heart rate? Let's say 70. And let's say how much did you get on KVT interval? Let's say you got 360. This one is in what? In milliseconds. You have to change it to milliseconds, okay? Otherwise you have to put it in seconds. So calculate it. So that's the QTC interval, which is around 388.8 milliseconds. So there are different calculations of QTC. This is the original Bazet's formula. The other ones are Felicia, Framingham, Hoyt's formula, all this. I mean, you don't need this all, okay? If you are like a doctor doing this, then yes, but for now, just know Bazet's formula. Okay. So now let's go to page 116, one heartbeat. So you can see one heartbeat contains what? Waves. Waves, what are the waves? P wave, Q, R, S, T, these are for waves. Then it contains segments. Can you see we have two segments here? What are the segments?
PR,
PR segment and
ST,
ST segment. Then we have intervals, what are they?
PR,
PR interval,
QT.
QRS complex is also an interval, but usually it's not said interval, usually it's said QRS complex. Because three waves come together, QRS complex. Then we have the QT interval, and we have also ST interval. We can have an ST interval from the end of S to the end of T wave. That's also ST interval. So these are called. This is in one heartbeat. So one heartbeat contains what? Wave, segment, and
interval.
intervals. So what you can do on this side is that write like this. Write a wave. Write the waves, segment, write the segments, write interval, write the intervals. So these are, basically the waves are here for you, here. These are the waves, segments, intervals. So when we say waves, the waves, they go what? Either up or
down.
down. So when the waves go up, it's called an upward deflection, or it's also called positive. Okay? When it's going down, it's negative or downward deflection. So in this case, which ones go upward?
QR?
Basically R is the one that's going up because it's up. Now P is going up, R is up, T is what? Up. Okay. What about Q?
Down,
Down, S.
down.
Down. Okay. So S, Q, and S, they are what? So usually they ask you like this a question. Which of the following is the first negatively deflected wave after P wave? So if you don't know this picture, so what you do always for EKG, always you need to know drawing this one, right on your side, you draw this one. Eindhoven, you draw like this and draw everything inside. These are very helpful for you when you answer questions. Which one is the next, which one is the next negatively deflected wave after P wave? What's that? Q wave, yes?
Mm-hmm.
Well, which one is the second negatively deflected wave after P wave?
S.
S. Okay. Which one is the last positively deflected wave after P wave? T. Okay. So they ask a question like this. Okay, any questions? If you know this, I think really it's not that much very complicated exam. But some students they second, but it's really very straightforward and it's very nice. Medical assisting and phlebotomy, they talk to you online. They talk to you. Yeah. So you need to know some communication skills and so on. How you communicate, how you educate patients, and on some medical ethics, HIPAA laws, regulations. They like also those stuff. Yeah. Okay. I don't want to lose you $117. One student, she came in, I will give you this one, can you take for me the exam? Yeah, it's not a good question, yes. Okay. I know sometimes it's hard, but really if you focus on the main points, may not be. Okay. Let's do a little bit here and then I will open for you the practice questions. We can do. So, especially the next part. So as I told you already the wave segments and intervals are here. Okay. So, some description. What do you mean by P wave? So always when you see a P wave, it means atrial depolarization. So this one tells you description. Atrial depolarization. When it's QRS, that's ventricular depolarization. When it's T wave, that's ventricular depolarization. U wave may not always be observed as a result of its small size. Prominent U waves are most often seen in hypokalemia. Hypokalemia means what? Low potassium. In low potassium, you can see that. So if you have a big P wave, there can be a sign of some electrolyte abnormalities. What do you mean by depolarization? Depolarization means a contraction. Repolarization means what? Relaxation. Okay? Yeah? Okay. Then let's go to page 118. So you can see normal heartbeat, how it looks like. Now tachycardia, fast heartbeat, look how it looks like. Bradycardia, look how the spaces are wider. Can you see? When it's tachycardia, how the spaces are what? Closer. And arrhythmia irregular, like that one. Look how the spaces are different. So, and this picture shows you how the atria is stimulated now ventricles, now recovery phase, repolarization. Okay. I think the next topics from ambulatory, point 120 is a different topic, so it's better to give it for next time. I will open for you. Do you want to be 2-2 or 2 each?